Okay, hi, my name is Pearl, and today we're going to look at this question. So we're to design the PLC. So given a push button IO, just so you know, the way push button works is when you press it, it turns on the lights or whatever you want to turn. But once you release the button, it turns off the motor. So just understand that that's the characteristic of a push button. So it says write a ladder program such that when IO is pressed, Q1 should come on, Q0 should come on for 10 seconds. So in order to do that, normally I'm going to draw the ladder logic now. Normally you have I naught is normally open switch. When it's turned on, it will turn on Q naught. But then once you release the push button, it turns off. So we don't want that. So we're going to add something. We're going to add what we call a memory bit. Memory bit is denoted with M. So what this memory bit does is in parallel with the normally open start signal. What it does is it saves the state that IO was in when you pressed it last. So if when you pressed it, it came on, you see MO will also turn on here, effectively turning on the circuit. Even if IO turns off, you can see that the circuit will still remain on. So at this output, just to segment it and make it look neater, MO will be here, and then MO will act as the new input for the motor keynote. So you understand this part. Now we want this to be on for 10 seconds. After 10 seconds, we want to switch off. So we're going to use a timer. This timer will start counting the second MO turns on. So we're going to use an on delay timer. This is a timer, we call it T1. It's a turn. And it's supposed to be an on delay timer. I don't know why it's the other way around, but okay. So this EN is the enable bit, is the output, or the done bit, this is the preset value, which is going to be 10 seconds. And this is the accumulator. Accumulator is basically just count 1 to all the way up to 10. Now the output is going to be a new memory bit that's going to temporarily store the signal. So now when M2, sorry, rather M0, yes, when M0 is enabled from here, it's going to start this timer. This timer will begin to count 1 to 10. When the timer is done counting, it will energize M1. Now, we want M1 to somehow turn off Q0, right? So we're going to do something. Whenever you want to model a start signal in PLC, it's always an normally open contact. When you want to model a stop signal, it has to be a normally closed contact. So we're going to add M1 to the beginning of our system here. We're going to add it as a normally closed contact. The output is still MO. So normally M1 will not affect the circuit. Normally current will be conducting. But the second M1 becomes energized since it's a normally closed contact. It will become a normally closed contact. It will become a normally open contact because it has now been energized, which means current will stop flowing, effectively turning off MO. And so therefore the motor cannot trips off. So this is just the program, the ladder logic for this system. Now I made a simulation I would like you to see so maybe you can understand this better. So this is a relatively simple simulation I made. I'm going to simply turn on IO and then I'm going to turn it off. You can see the state still remains. Now it powers on MO powers Q naught, and MO starts the timer. You can see it's counting 1 to 10. The second it reaches 10, it's energized M1, and since M1 was a normally closed contact, it became normally open here and therefore effectively turned off our circuit. So I hope you understood. Any questions you have, just don't hesitate to ask in the comment section. Thank you for listening.